Now let's start the assembly. Um, I've opened up a new assembly file, the metric standard, and we want to place, actually we want to place the base part first and build up from there. So we'll bring that in, place one component, and don't freak about the orientation. It's a metric file, so it defaults to first angle projection a lot of times. So what we'll do is flip up and get our front right top corner, right click on the home button, and go set current view as home, fit to view. Okay. Now, whenever we hit the home button, it'll come back to there. So we got this base in, it should be grounded. Let's bring in the frame, part number one. Oh, I grabbed the wrong one. Sorry. I'm working on vids. And we'll place one instance of it. Now, we're going to use a kind of a mixture of constraints and joints as we're going through with this. Kind of help you as you practice with both of them. You'll start to see some circumstances where constraints are better, some circumstances where joints are better. So for this one, we're going to use constraints, and let's go with a mate that surface to this surface, and I'll apply that, and then we'll go with an axial constraint through the holes. Okay, and so that's got it in place, but it'll still rotate. And in real life, there would be some movement allowable in it, but we want to constrain it so that there's no movement. Okay, and I'm going to expand my origins, and I'm going to do a constraint of planes, and I want to pick not those planes, but because we've created everything based on the planes, we're going to go with the XYs. Well, that didn't, oh, flush. There we go. The order in which I picked them determines that. All right, and so now that thing is fully constrained. And so let's bring in the pins, and they are, what are they? Part number 6. And let's pop 2 instances of these in. And for these, let's use a rigid joint. Now, these things, the shoulder of the pin goes in here, but the face of the shoulder mates against this surface, and that's as far in as it will go. So I'm going to hide visibility of that, and we'll do the joint here. So let's go joint, and let's go ahead and choose rigid. And part number 1, I want to be sure and get that surface. And part number 2, we'll get that surface in the center of the hole. Cool. And now we're going to align, and it automatically picks a surface there. And then for number 2, I'm going to choose the vertical surface here. And I'm going to go OK. Now that constrained it in place and prevents it from rotating. Okay. And so we'll do the same over here. And when you're doing joints, you always pick first the one that you're going to move. And now we have to flip the component, and let's do an alignment just like we did before and apply that. Oh, it didn't take. That was weird. So let me go in and edit that. Oh, I let it go to rotational. Sorry, it should be rigid. There we go. Now we're good. Now I can turn back on visibility here. And so if you look closely, you'll see that the screw is not totally tight against this, because in real life, this part would be able to move. Okay, so next, let's see. Let's bring in the pulley and 2 washers. Oh, bid 2. And the washers. Part 4, okay. All right, and so with these, an axial constraint and a mate constraint will work easiest with these, I think. So we'll go constrain, and let's go with that axis. And with the washers, you kind of have to zoom in until you can hover over the face of the cylinder. And we'll apply that. And I'll have to drag it out. Okay. And now we'll do a mate constraint of face to face. Okay. And now let's go ahead and do the mates first. And now we can do the axes. Okay, so now those are kind of a sub-assembly, and as you'll see in some future projects, you can actually create an assembly, a sub-assembly, and then bring it into an assembly. And we're going to do that in one of the projects in the future. Okay, so this thing, let's see, what's next? All right, now we're going to insert it into this area here. So once again, we'll go with an axial constraint of the holes. Okay, and so it's constrained to the axes there, so it's in there. But if you remember our measurements, if you take the measurement of the wheel and the 2 washers and subtract it from the distance between here, you end up with 1 millimeter of space. So what we want to do is center that space with a mate constraint. And it doesn't matter which face, but we'll give it a 0.5 offset. Okay, and so now that is constrained, except for it will rotate. And the washers will too. The washers aren't that big of a deal. So let's go ahead and constrain the wheel with an angle constraint. And we'll do a directed angle. And so I want to go with, oh wait, is it part number 2? Yeah. So I'm going to go XY plane to XY plane. And it's 0 degrees. Okay, so now that is constrained. And let's go look at our degrees of freedom. And you can see I've got rotation on the washers, which really won't matter because if they rotate, it's not going to change the drawing, okay, in any fashion. All right, so let's see next. Let's bring in the shaft and the bushing. Okay. Now this one's going to get a little interesting. So let's hide the frame and a washer. And we want to do some axis constraints and some angle constraints with these two parts here. And so I'm going to take temporarily, let's collapse these things down. I want to temporarily ground that shaft so it doesn't move as I'm trying to work with things here. All right. And so now let's do, I want to do an angle constraint that keeps the keyway, the oil groove over the keyway, because it'll work out better for our drawings. So let's go with another angle, one direction, and choose one face of the keyway, or excuse me, one face of the oil groove, and then a face of the keyway, and 0 degrees. I could have gone axes, axes planes, that would have worked also. Now let's do an axis constraint through there and through here. Okay, so now that's got it. It's in there, it'll slide, and that's okay for right now. I could have done, a joint on that, I guess, a rotational joint, but then I would have had to have applied an angle constraint to it anyway. Okay. And then what we'll do is let's do an axial constraint. Oh, wait. We'll wait about that. Okay. Let's save this. And it is going to be 14-39 because it's the assembly. And let's bring in a key, a Woodruff key. So we're going to go place from Content Center. And over here, you're going to navigate down to shaft parts, keys, Woodruff, and we want the full radius. And I remember in previous video, I turned off auto drop. I find it works easier to do it manually. And here I want to pick the size, and these are based on shaft diameter. Okay, as you scroll down and you see the sizes on the right changing, and so I know that we are using a number 406. So I'll place OK and place one instance of it in here. All right, so let's free rotate this to kind of get it somewhat close to the right orientation. Now let's do a series of constraints, and I'm going to do a mate on the back side and a mate on this side. And then I want to do a tangent with the bottom of the key slot. And I want to choose the inside, okay. And then we want to do an angle constraint. And let's see, I'm going to go with an axis here. So we'll go with an angle constraint of the top of the key to an angle of 0 degrees. Okay, so that is locked to the shaft. This can slide, but other than that, it's locked to the shaft. So let's unpin the shaft, unground it, and then let's go ahead and put our cylinder, our bushing, inside the wheel. And then because it's the same width as the wheel, they're both 63, we'll do a flush constraint on the outsides of those. And so that gets the bushing in there. Now if I just drag my key in, you can see it actually comes inside the washer, okay? But this thing will still rotate at this point. So it'll rotate and slide. All right, so let's back out and let's turn on the visibility of the frame and turn off the visibility of the wheel and the other washer. Yeah, it'll be easier if I turn off the bushing also. So I've got this, and I think to make things easier, I'm going to slide it way out here. And what we want to do is get this aligned with our slot. So let's check the size on this. Let's go Tools and measure. That is 3.175, and we have, what do we have, 3.2, okay? So now we could do a mate on the side. Let's see what our axis planes are like in that. That will work beautifully. Okay, and so let's open up our origins on that. And so let's do a mate constraint. Between that plane and the same plane on our key. Okay, and now let's slide this back in so we can check it. It's actually a little bit bigger than our key slot because we made our slot based on the textbook, but the key is, you know, real life size based on Inventor. Okay, and so now we need to do a mate constraint against this side and the corresponding side of the shaft. Okay. All right, let's turn the visibility of everything back on. I'm going to collapse these down. Alt-V. I'll have to remember that. Alt-V. All right, so we're assembled. So let's go to wireframe view so that we can look at these things and see if we can notice any conflict, okay? And if you rotate it, it gets a little weird. So there's the frame. I don't notice any conflict with the frame. There's the wheel. But you got to remember the inside of the wheel is less than the outside of the wheel, so the washers are against that. There's clearance. We've got the bushing here. That looks good. The key, it looks like the key is up a little bit into the slot. I think that's because of the size of the actual key from Inventor. And you remember in our previous video where we actually made a drawing to pull it in. Yeah, it sticks up just a little bit. So Let's go back and edit the depth of that. Tell you what, let's come out of here. I want to hide this so I can, oh, that doesn't work, does it? Duh. What I'll do, I can suppress this constraint and then pull this out. And now I think I can get a measure tool to work to go from that line down to that plane. 0.068. So we've got a interference of 0.068. I'm gonna write that down, 0.068. So I need to make one of these slots bigger. So let's come in here and edit. I'm gonna open it. It'll be easier if I open it. So I need to decrease this. So I'm just going to say minus 0.068 millimeters. A decimal helps, huh? Finish sketch, save it, go back to the assembly, update. I'm going to push it halfway in and go to wireframe. That looks good. I mean, our lines are like right on top of each other. Let's go to this side view. Well, our key is actually wider than the slot. I think that will work for us right there. We'll go with it and call it done, huh? Okay. So I'm going to close that back down and turn that mate back on. Okay. So that's got all of these things. Check my degrees of freedom, and that's my two washers. All right, so I'm going to pause this video and then start another one to finish up.